in a topological state or conductor. The jelly is that new molecule. That molecule now is being used like a qubit. What they announced is they can take this molecule one at a time. They can put millions of these molecules onto this chip.
Scientists are confronting a discovery so unsettling that it threatens to upend our understanding of reality. A quantum chip so powerful, it appears to be unraveling existence itself, not in theory, but in real time. The Majorana 1000 Qubit quantum chip has just completed its first full-scale test, and the results have sent researchers into a state of alarm. Lab footage captures flickering screens, corrupted data, and anomalies that defy the fundamental laws of physics. Clear evidence that something has gone catastrophically wrong. Witnesses describe quantum states reacting to forces beyond our universe, calculations rewriting themselves retroactively, and outputs that defy causality. This isn't a mere malfunction. This isn't an exaggeration. This is a machine pushing beyond the boundaries of known physics, leaving its creators to ask one terrifying question. Have we just broken reality? At the heart of this controversy lies the Majorana chip's design. Unlike traditional qubits, which are notoriously fragile and prone to decoherence, Majorana qubits are stabilized by their topological properties. Named after the enigmatic physicist Majorana, these particles act as their own antiparticles, existing in states that are theoretically immune to external interference. This topological protection promised a quantum computing revolution. Machines capable of solving problems in minutes that would take classical supercomputers millennia. But when researchers scaled this technology to 1,000 qubits, they encountered phenomena that defied explanation. The chip wasn't just calculating outcomes. It seemed to be interacting with them. One scientist involved described it as watching a calculator argue with itself. Then, the real horror began. The team noticed anomalies that defied all logic. Data outputs mysteriously changing after the fact, as if an unseen force were rewriting them. Quantum states remained in superposition far longer than physics allowed. But the most unsettling revelation was still ahead. Some calculations were completing before their inputs were even entered, suggesting a disturbing reversal of cause and effect. As the implications became clear, theorists proposed a daring hypothesis. The chip wasn't just processing information. It was tapping into alternate timelines, retrieving data from parallel realities where different choices had been made. Could this explain why the Mandela Effect, collective false memories of events that never happened, has surged in recent years? Or why AI systems like ChatGPT sometimes produce answers that feel eerily prescient? Here's where things get existential. If the Majorana chip is indeed bridging realities, the implications are staggering. Every calculation it runs might be altering the fabric of our universe, creating ripple effects that rewrite history, memories, and even physical laws. Imagine waking up to a world where a long-dead celebrity is suddenly alive, or where your childhood home never existed. Some researchers fear we've already passed a quantum event horizon, a point of no return where changes cascade uncontrollably across timelines. Others argue that the anomalies are merely computational errors, amplified by the chip's unprecedented complexity. But how do you troubleshoot a machine that might be malfunctioning in multiple realities at once? Midway through this crisis, a chilling question emerges. Could the chip's creators have inadvertently handed control of our reality over to an algorithm? Quantum systems function on probability, simultaneously processing countless possibilities. With 1,000 qubits, the Majorana processor may be generating outcomes so vast and interconnected that it's effectively determining which timeline we experience. This isn't just a machine, it's a cosmic editor, altering reality with every calculation. And if that's true, how can we be sure we're still in the original 2025? If your reality feels off lately, could this be why? Drop your thoughts in the comments. Have you noticed any strange glitches in the matrix? The debate among scientists is escalating into a schism. Some advocate for an immediate suspension of Majorana-based research, warning that further experimentation could destabilize space-time itself. Others believe halting progress out of fear would be a mistake, arguing that we must continue to study and potentially control this phenomenon. The stakes couldn't be higher. If the chip has already entangled our universe with others, shutting it down might sever vital links, trapping us in a fractured reality. Conversely, keeping it operational risks irreversible contamination, akin to filling a sealed room with smoke until it becomes unbreathable. Skeptics, however, urge caution. They point out that quantum anomalies often seem mysterious until properly analyzed. Retroactive data shifts could be artifacts of quantum teleportation. Time glitches may result from synchronization errors in classical computing. And even the Mandela Effect might be explained by the brain's tendency to blend similar memories. But the sheer scale of the Majorana chip introduces variables we've never faced. At 1,000 qubits, the system's complexity dwarfs anything built before, operating in a mathematical space larger than the number of atoms in the observable universe. In such an environment, could new physics or new metaphysics emerge? Stay vigilant. The Majorana fermions at the chip's core are quasiparticles that exist in superconducting materials, behaving as if they are half an electron. Their topological protection arises from their non-local encoding. Information isn't stored in a single location, but spread across the system, making it resistant to local disturbances. Scaling to 1,000 qubits amplifies this effect exponentially, enabling error rates low enough for practical applications. However, it also creates a Hilbert space, the realm of quantum states, so vast that even minor interactions could produce emergent phenomena. Critics contend that the observed anomalies stem from qubit crosstalk or thermal noise rather than any effects linked to a multiverse. However, until the chip's behavior is fully understood, the line between groundbreaking discovery and critical failure remains perilously thin. Scientists are now examining reports of unusual phenomena emerging from the first full-scale test of the Majorana 1,000-qubit quantum chip, a device designed to leverage the unique properties of Majorana fermions, quasiparticles that act as their own antiparticles. Unlike conventional quantum systems, these fermions store information non-locally, theoretically rendering them resistant to external disruptions. Yet, recent experiments have uncovered unexpected behaviors that challenge established principles of quantum mechanics and its connection to observable reality. The test revealed anomalies in data processing, including outputs that appeared to retroactively alter input parameters. For example, a prime number factorization test initially produced correct results, but the inputs and outputs later shifted to align with a different set of primes despite no changes being made to the original data. Similar inconsistencies have emerged in other experiments, such as protein folding simulations, producing structures later found in historical research papers that had previously not contained them. These observations suggest the system may influence or access data outside the bounds of conventional cause and effect. A central concern is whether the chip's operations could inadvertently interact with alternate timelines or quantum states. Some researchers hypothesize that its unprecedented scale, 1,000 qubits, generating a mathematical space larger than the number of atoms in the observable universe, might enable emergent phenomena. Phenomena like cross-reality data exchange could provide fresh perspectives on widespread false memories, often called the Mandela Effect, cases where large groups of people misremember historical events. What makes this even more fascinating is that these occurrences became more frequent after the activation of the experimental quantum processor known as the chip. Further concerns have emerged from what appear to be temporal anomalies linked to the chip's operations. In one particularly striking case, an advanced AI model, trained on datasets processed through the chip, generated highly accurate stock market predictions, astonishingly, hours before the corresponding corporate announcements were made public. While skeptics argue that such predictions could be explained by data leaks, pattern recognition, or sheer coincidence, some researchers propose a more radical possibility, that the chip's quantum processes may grant a form of probabilistic foresight or even exert subtle influence over future events. While these claims have yet to be verified, the repeated occurrence of anomalous results across multiple experiments has sparked pressing concerns. Some experts call for further investigation, warning that dismissing these findings too soon could mean missing a groundbreaking discovery. Others, however, urge caution, emphasizing the risks of speculative interpretations and the potential unforeseen consequences of relying on the chip without fully understanding its implications. The scientific community remains deeply divided on the way forward.